All right, so last time we started to study imperfect competition. We looked at the Cournot model, but the bigger theme is the study of how firms compete outside of the sort of easy cases that you study in 115. So outside of the example of monopoly, where there is only one firm and so there's not much competition, and outside the case of perfect competition, where there are so many firms, it's as if each firm is a price taker. All right? And we're going to continue with that today, and in fact, you're going to continue with it on into the homework. So last time, we looked at Cournot. That was the model we started with. We looked at two firms competing in quantities. And just to review a little bit what we did last time, the kind of exercise there. So I think, is this right? I think I probably went a little fast last time. I was kicking myself afterwards. I don't know, people can nod or shake their heads with it. I think I went a bit fast. So I'm sorry for that, but if there was a time to go too fast, it was probably last time, because it turns out this is something that's covered very well in the textbook. So it's covered in chapter 6 of the textbook. But the kind of exercise we did last time is a useful exercise for those of you who are econ majors. The way we solved that Cournot model was we did three kinds of things. We did something very nerdy, namely we just played with calculus and algebra. All right, that was sort of mathy. We did something a little bit less nerdy, that is we drew some pictures that represented what we'd found. And we did a third thing, which was we tried to match this up to the economic intuition about monopoly and perfect competition and demand curves and so on. And this exercise of being able to work in these three different modes, economic intuition, graphs, and kind of nerdy high school math, is a lot of what we want to get you used to as economic majors, is to be able to translate easily between those. So again, I apologize for going too fast, but it's still a useful exercise, I think. So have a look at it in the book. Now back to the lessons and away from the nerdiness a second. What did we learn? Well, at the end of the day, we learned that in the Cournot equilibrium, things were, as we perhaps might have anticipated, things were sat naturally between the extreme cases. So the amount of output produced by the industry was somewhere between the case that would be under monopoly and under perfect competition. It was more than under monopoly, less than perfect competition. Prices in the industry, if we'd gone back and checked, would sit between. They would be lower than the monopoly prices, but higher than the perfect competitive prices. Industry profits would be in between. Industry profits would be less than monopoly. They must be less than monopoly, since that's the highest they could ever be. And they're higher than perfect competition, which, of course, has zero profits in this case. All right? And consumer surplus, the benefits flowing to consumers, lie in between. So in fact, the model, in addition to the sort of nerdiness of the model, it ended up with the result we kind of believe in. If you have imperfect competition, it's somewhere between perfect competition and no competition. But, what's the but? The but is that there are other ways we could model imperfect competition, and as we're going to see today, they yield different answers. So the first thing we're going to do today is look at a different form of competition, which is called Bertrand competition. So Cournot was competing in quantities, and Bertrand is competing in prices. All right? And just a quick check, and this is not for the camera, how many of you have seen Bertrand competition before? So a good many of you. So this is going to be a review still. Again, for those of you for whom which it isn't review, don't worry. Don't worry. We'll do this relatively quickly, but I hope I won't rush it like I did last time. If it's any consolation, when I feel I've rushed a lecture, I have a sleepless night. So if you had a sleepless night because you're worried about it, think of, I'm having a sleepless night too about that. All right. So there's two firms, just as there was before, and just as there was before, so the players are those two firms, and just as there was last time, they're producing an identical product. All right, so the products we mentioned last time were Coke and Pepsi, but you could think of other products that are pretty much identical. Right? And just as last time, we're going to assume that costs are constant marginal costs. We'll assume that constant marginal cost, just as it was last time, is equal to C. Just to remind those people who are not economics majors what that means, it means if I produce 1 unit, then it costs me C to produce. If I produce 2 units, it costs me 2C, 100 units, 100C, and so on. All right? Now what's different here from last time, well, I've already told you, but I'll repeat it. This time, however, instead of setting quantities, instead of just deciding how much Coke and Pepsi to produce and spewing it out in the market and letting prices take care of themselves, this time the firms are going to set prices and let quantities take care of themselves. All right, so the strategy set this time are prices. And again, so we don't get confused, normally we use S for strategy, but let's use P since they're prices. So they're going to be P1 will be the price of good 1, of firm 1, and P2 will be the price of firm 2. And the strategy set, formally, let's just to simplify here, let's assume that for each firm I, they can set their price anything bigger than 0 and anything less than 1, just to keep life simple. All right? So this is a little bit more realistic, perhaps. Right? It's perhaps more realistic to think of firms actually thinking about what prices to set and then adjusting the quantities they actually ship based on demand. All right? It depends. I don't want to be too rigorous about that because you could imagine the other way around. But this, if you talk to managers, this sounds more realistic, at least for retail goods like Coke and Pepsi. All right. So we know how prices are set. They're set by the firms. So the next question is, where do the quantities come from? All right? So where do the quantities come from? And they're going to come from demand. And let me use a big Q of P, to be the total quantity produced, the total quantity demanded in the market. So this will be the total quantity of goods produced by firm 1 and goods produced by firm 2 that are consumed. All right? So this is the total quantity of Coke plus Pepsi. All right? And we're going to notice there's no subscript on this P, and you'll see why in a second. So we'll assume, just to make life simple, that the total quantity produced is 1 minus P. And I'll say this and then write it more carefully, where P is the lower of the two prices. All right? So the total quantity demanded is 1 minus P, where P is the lower of the two prices. All right? Now, to make that lower of the two prices comment a little bit more rigorous, let's figure out what the demand actually is for these firms. So what's going on here? So let's look at the demand for firm 1, all right, which is going to end up being the quantity that they sell. So that's going to be Q1. And what's that going to be? Well, it's going to be 1 minus P1 if they're the low price firm. So if P1 is less than P2. Right? So if they're the low price firm, if Coke is the low price firm, only Coke sells in the market, there's no Pepsi in the market, and 1 minus P1 quantity of Coke is sold. It's going to be 0 if P1 is bigger than P2. Right? So if Pepsi is the low price drink in the market, then no Coke is sold at all. And it's going to be 1 minus P1 over 2 in the case where Coke and Pepsi cost exactly the same. Right? You should already be realizing this is not exactly realistic. Right? We're making a lot of very strong assumptions here. But nevertheless, it's going to be instructive to look at this model. All right, so I've got the firms, they're the players, I know what their strategies are, I know a little bit about the structure of the market, I still need to tell you what payoffs are. And just as last time, the firms are going to try and maximize profits. All right, so what's the profit for firm 1 going to be? I won't bother to write it separately for firm 2. It's going to be the quantity it sells times the price it gets for that quantity, minus that quantity it sells times the cost it incurs in producing that quantity. So again, it's for firm 1, it's the quantity it sells times the price, this is its revenue, minus the quantity it sells times C, the cost, this is its cost. All right, I can rewrite that a little bit more simply as Q1 brackets P1 minus C. right? Where Q1, where this Q1, let's keep it in square brackets, this Q1 is this object here. Right, does everyone understand what's going on? I mean, the algebra doesn't really help the intuition here. The intuition is pretty straightforward. Coke and Pepsi are producing this stuff. They're setting prices. If Pepsi is the low price, then Coke sells nothing. If Coke is the low price, it sells this amount, and its profits are basically given by this equation. It's basically just revenues minus costs. All right, so what we want to do is we want to figure out what the Nash equilibrium looks like in this market. And just before we go any further, notice that really this is the same basic market we looked at before. Right? Both times there's a demand curve out there. In one model we thought of the firm setting quantities and the market determining prices. And here we have the firm setting prices and the market determining quantities. But the basic underlying economic structure of this is very, very similar. All right, so to find the Nash equilibrium, we're going to have to find best responses. All right, so what we're going to do together is to figure out what these best responses look like, and let's try and do that. So I want to figure out the best response of firm 1 as a function of the price chosen by firm 2. The best price for firm 1 to choose, given that firm 2 is choosing P2. And I want to do this carefully and slowly, and before I even start, let me point out in passing that calculus is not going to help us here. All right, so for those of you who are nerdy enough to understand the next sentence, let me just say it. This is a discontinuous payoff function, so differentiating isn't going to get you very far. All right, for people whom that didn't mean anything, doesn't matter. We're not going to use calculus today. All right. Okay, so there are different cases to think about. So one case to think about is, what if the other firm, your Coke, what if Pepsi is pricing below cost? What if Pepsi is pricing below cost and you're Coke? What should you price at if you're trying to maximize your profits? Somebody try and wave their hands in the air if they know the answer. Pepsi's pricing below cost. What's your best response? Yeah, there's a guy in there. Do you want to shout out?
Just get out of the market because it's not worth it for you to sell anything.
Right, so I've forgotten your name, I should know it by now. Your name is?
Sudipta.
Sudipta says, get out of the market, right? If the other guy is pricing below costs, you don't want to sell anything. That's the right intuition. How in this game do I, quote, get out of the market? You're absolutely right. I don't want to be involved in this market if the other guy is selling below cost. How do I operationalize that in this game? How do I actually manage? There's somebody here. So just wait for the mic a second, and I'll shout it out.
You could set your price above his price.
So the answer was set your price above his price. So the other guy is pricing below cost. The way in which I avoid making losses is to set my price above his price. Right, let's just make sure we understand this. If the other guy is selling below cost, the only way I can make any sales is to price below his price. I will then make sales, but each of those sales I'm making a loss on. I don't want to make losses, so I just, quote, get out of the market, and the way I, quote, get out of the market is by pricing above the other guy. All right, everyone understand that? All right? Okay, so now, more interestingly, let me leave a little gap here. What if the other guy is pricing above costs? What do I want to do if the other guy is pricing above costs? Ty, can you get the guy with the beard here? Shout it out, because remember that mic isn't amplifying.
You set price below his, but above or equal to cost.
All right, so if the other guy is pricing above costs, I want to set prices below his so that I steal the whole of the market and make profits on those sales. So so suppose he's pricing at, we said the prices are between 0 and 1, suppose he's pricing at 0.8, what would be a good price for me to set? Same guy, yeah?
As a small amount below his price as you can do.
A small amount below his price as I can. A small amount below his price as I can. So basically what I'm going to do here is I'm going to set my price to equal his price minus a little bit. And I'll use the letter epsilon to mean just a little bit. I'll just undercut him a little bit. And by just undercutting him a little bit, I'm going to get the whole of the market, and I'll make as much money as I can on those sales. Now that's almost right. That's almost right. That's kind of 90% of right, but it's not quite right. I need to be a little bit careful. Now, why do I need to be a little bit careful here? So this is almost right, but it's not quite right. Yeah, same guy?
You want your price to be at or above cost.
Okay, that's certainly true. Okay, so that's true. So fair enough. So I want to make sure this epsilon is not so big as it pushes me below cost. That's certainly true. That's correct. There's another little issue here. So here's the other issue. There's a price in this market we might want to think of as a kind of focal price. There's an interesting price, and that's the price at which the price I would choose were I the monopolist. Right? Suppose the other guy didn't exist. Suppose Pepsi didn't exist, so Coke has the whole market. Right? Then we would solve out this problem. We would solve out what the monopoly price is. That's an exercise you did in 115. All right. And notice that if Pepsi has priced above the monopoly price, right? Suppose Pepsi has priced this good so high that it's above the monopoly price, then as the gentleman said, I can capture the whole market by pricing just below Pepsi. However, then I'll have the whole market. It's as if I'm a monopolist, but suddenly I'm pricing above the monopoly price. That can't be right. Right? I never want to price above the monopoly price because I know the monopoly price, when I'm the monopolist, is the most profit I could ever make. Is that right? Right? So we need to be a little bit careful. This answer that says I just undercut Pepsi, that's true provided that Pepsi hasn't gone above the monopoly price. Right? If he's gone above, if he's gone above the monopoly price, we need to be a little bit more careful. If P2 is actually above the monopoly price, then what's my best response in that case? What's my best response in that case? Yeah, can we get Katie, who's in green there? Shout out.
Pricing at the monopoly price?
Pricing at the monopoly price. So if Pepsi is dumb enough to price above monopoly, sure, I will undercut Pepsi, but I won't undercut Pepsi by a penny. I'll undercut Pepsi all the way down to the monopoly price and make monopoly profits. I'll be very happy. I'll be wondering what on earth is Pepsi up to, but that's fine. All right, so here, my best response is to price at the monopoly price. All right, and there's one other possibility here I've missed, which is what if Pepsi prices at marginal cost itself? That's the one missing case here. What if Pepsi prices at marginal cost? What's my best response in this case? Pepsi's pricing exactly at marginal cost. What's my best response? Yeah, wait for the mic. This is Henry, I think. Shout out.
To price at marginal cost as well.
I could price at marginal cost as well. How much profits will I make if I price at marginal cost as well? Zero profits. I'll make zero profits. So that certainly is a best response, pricing at marginal cost as well. What else would be a best response? That's correct, but what else would be a best response? Price above that, all right? It doesn't really matter as long as I don't price below it, all right? As long as I don't price below it, I'm not going to make any money anyway. Right? If I price below it, I'm going to lose money. All right? So this best response actually is a pretty complicated object, and we could, if we're going to go like we did last time, we could take the time to draw this thing, but it's a bit of a mess, so I won't worry about doing that right now. All right? The best response is actually pretty complicated, even though the best response is pretty complicated, and by the way, obviously the things are symmetric for player 2, even though these best responses are pretty complicated, it turns out that there's only one Nash equilibrium in this game. What's the Nash equilibrium? Somebody watch the Nash equilibrium. Raise your hand. All you guys, there's a huge number of hands who said they'd seen it before. So who saw this model before? Fewer hands go up when they know there's a question coming, right? There's a different incentive, all right? Who remembers what the Nash equilibrium is? Yeah, there's a guy right by you there.
At C.
Shout that out, 'cause even I can't hear you.
At C.
At C, okay. So the Nash equilibrium here, the Nash equilibrium is for both firms to set their prices equal to marginal cost. And you can check that both firms are then playing a best response, so that's all right. If firm 2 is charging C, then a best response for firm 1 is to set, let's put the ones in here, is to set price equal to marginal cost. And if firm 1 is setting pricing at marginal cost, then conversely, a best response for firm 2 is to price at marginal cost. Right? Slightly harder exercise is to check that nothing else is in Nash equilibrium. Well, let's think about that for a second. Suppose firm 1 is pricing at marginal cost, and firm 2 is pricing at something higher, at C plus, I don't know, 3 epsilon, a little bit higher. Right? Suppose firm 1 is pricing at marginal cost, and firm 2 is pricing at C plus 3 epsilon. Is this a Nash equilibrium? Let's think about firm 2 first of all. Is firm 2 playing a best response to firm 1? Is firm 2 playing a best response to firm 1? So I claim it is, right? Well, let's just check carefully. Firm 1 is pricing at marginal cost, right? The best response if the other guy is pricing at marginal cost is to price at marginal cost or above. And this is marginal cost or above, so this is a best response. So firm 2 is playing a best response. This is a best response for firm 2, given that P1 is at C. What's the problem here? Why is it, nevertheless, I claim this is not a Nash equilibrium. Why is it not a Nash equilibrium? Who has an incentive to deviate? So can we get the guy way at the back, way at the back by the door? Go ahead. Shout out.
Firm 1's going to want to produce at C plus 2 epsilon.
Exactly, exactly, exactly. This is not a best response. This is not a best response. And the reason is that the best response for firm 1, if firm 2 is charging C plus 3 little bits, is to price at C plus 2 little bits. Thank you. All right? So it turns out it's pretty easy to check that this is the only Nash equilibrium in the game. All right. Now, what's the lesson we want to draw from this? Well, as an exercise in game theory, that really wasn't very hard. All right? As an exercise in finding Nash equilibrium, by this stage in the course, most of you are looking at that saying, yeah, that wasn't hard. So what's the point here? The point is that in this game, in which firms competed in prices, even though there were only 2 firms in the market, right? Only one firm more than monopoly, right? We get a dramatically different result than we had last time. In particular, we find that prices in the market are equal to marginal cost. We find that profit in equilibrium is equal to what? 0. And we find there's lots of consumer surplus because prices are really as low as they ever could be. In fact, the outcome here, this equilibrium here, is, for all intents and purposes, the same equilibrium we would have had there been thousands of firms in the market and had this been a perfectly competitive market. Right? So even though there's only 2 firms here, with price competition, identical products, we end up with an outcome that looks exactly like perfect competition, except that for the fact there's only 2 firms. Right? So the outcome is like perfect competition, even though there's only 2 firms. That's a pretty surprising result. It would suggest, think about this as a policy thing. So if you believe this model, if you think this is really an accurate model of society, and you're a regulator working in the Department of Justice, or you're a judge trying to judge some monopoly case, or you're a commissioner on the European Court, or whatever, trying to judge some competition case, all you'd worry about is getting 1 competitor in each market, 2 firms in each market, and you'd be done. Right? You wouldn't worry about entry beyond 2. All right? Now, my guess is we don't believe that. We don't believe that. All right? We'll come back to that in a second, but let me make a different remark before we get there. Is that me doing that? Let me move this down. All right. Still doing it, okay. It's probably the wire. Sorry.
Check the belt pack on the room microphone, which is...
Let me just remove it and I'll shout. Okay, I'm going to shout now. Can people still hear me? Can people still hear me? Yep, okay, thank you. All right, so we'll have to turn down the other mic a bit. All right, so what's another thing to remark here is even though we looked at essentially the same market as we looked at last time, and we didn't make any really significant change. We just said, instead of thinking of them pricing in, setting quantities, think of them setting prices. These were just thought experiments. We ended up with a radically different outcome. All right, so another lesson here is the same setting as last time, as Cournot, but with a different strategy set, a different way of thinking about what they're doing, led to a very different outcome. And that's worrying, right? It's worrying because you can't go away feeling comfortable about this. You can't think that it really could make so much difference in the real world how prices and quantities and welfare and profit is going to work out depending on some thought experiment about how I think about my strategy set. All right? So there's a little worry going in about not just this example, but about the course, about the whole theme of learning game theory. All right? So what's going to save us here? What's going to save us is if we inject a little bit more reality back in the model, we're going to get back a more sensible result. So what we're going to do now is we're going to relax some of the assumptions of this Bertrand model, and it's going to do two things for us. First, it's going to give us an outcome that we believe. The outcome we believe, I think, is that imperfect competition should look something between monopoly and perfect competition. It shouldn't look like perfect competition. I think most of us don't believe that two firms is enough to make for perfect competition, that the regulator shouldn't worry about the third firm. All right? And the second thing it's going to do from a more theoretical point of view is it's going to suggest to us that actually things aren't quite as bad as we thought. In fact, if we model this more carefully, we'll get roughly the same prediction either way. All right? So what's the assumption we're going to change? Well, before I say that, I should say I'm not going to change it. You are. All right? So rather than go through this again a whole third time, I've gone through it once in quantities and once in prices, I'm going to get you guys to do it this time by having you do it on a homework assignment. And, well, why? Well, partly because I think it's a good exercise, but also I don't want this class to be a class where you sit there, you know, with your cup of Willoughby's coffee, if needed to keep awake, and you watch me solve models, because that's not how you learn. What I want this class to be is a class where at least sometimes, like in this homework assignment, I set up a model for you, or set up the story for you, and then you have to actually figure out how do I set this up properly and how do I solve it out. Because in the end of the day, if game theory is going to be useful for you in your later lives, whether it's in dating or in running a company or whatever it happens to be, you need to be able to go from the story to the model. All right, having said that, I'll tell you what the homework assignment is going to be about. The assumption we're going to change is the idea that products are identical. Right, so we're going to look at a case. I need a new board. Where products are differentiated. And I'm going to claim that assuming that products are not identical is a pretty safe assumption for most of the world, for most things that you're going to see in the world. So we're going to look at what are called differentiated products. And in particular, we're going to look at a particular version of this that we're going to call the linear city model. All right, so what do I mean by products being differentiated? So I started off with an example that's pretty bad for this story, namely Coke and Pepsi. Now, be honest, how many of you in a blind taste test can taste the difference between ordinary Coke and ordinary Pepsi? Oh, quite a few. OK, that's good for my case, right? So a number of you think those are different products, right? So a number of you, even if their price was just a tiny bit different, might have a preference for one rather than the other. So without getting in trouble by putting the camera on you, how many of you would have a preference? If the prices were essentially the same, how many of you would have a strict preference for Pepsi? And how many would have a strict preference for Coke? And how many would have a strict preference for Diet Coke? That's amazing. That stuff's, oh, never mind. Okay. Okay, but you're making my point. The point I'm trying to make is products are not identical. All right? Products are not identical. Okay? For the most part, there's a little bit of difference between products, and that's actually going to, if we inject that little bit of realism into the world, it's actually going to help us. So what would we like? We'd like a model in which firms set prices, because for the most part, we think firms do set prices, not quantities. Not always, but for the most part. But we'd like a model that yields an outcome that looks, that when you only have two firms, looks somewhere between monopoly and perfect competition. So we'd like an outcome that looks a little bit like Cournot, but we'd like the strategy set to be prices. And this is going to do the trick. This is going to turn out to do the trick, as you'll find out in your homework assignment. So how are we going to model this on the homework? The way we're going to model differentiated products is to imagine, just to take a simple example, imagine a city, and this city has one long straight road through it. So this city is not a city in New England, it's a city in the Midwest where everything's flat and the roads just go completely straight. All right? And you can think of it as being, I don't know, a mile long, doesn't really matter. All right? Let's think of it as being a mile long. And we're going to assume that consumers are evenly spread along this city. Right? Consumers are evenly spread along this city. So there's basically consumers everywhere. They're evenly distributed. And we're going to assume that one of these firms, let's call it firm 1, sits at point 0, and the other firm, firm 2, sits at point 1. Now this is what you're going to do in the homework assignment, but let me just make the argument that you could also imagine firms sitting somewhere between 0 and 1, right? We could do a more general job if we wanted to. But for now, let's assume that one of these firms has its shop at one end of the town, and the other one has its shop at the other end of the town. All right? So let's think about a particular consumer. So suppose this consumer is here, point Y, say. All right? So notice that this consumer is a distance y away from firm 1. So if she consumes from firm 1, she has to walk a distance of y. All right? And she's a distance of 1 minus y from firm 2. Is that right? So if she consumes from firm 2, she has to walk 1 minus y. All right? That's going to turn out to be key in our model, as we'll see in a second. All right? So firms, as before, are going to set prices. And I won't write everything down because it's all written down on the homework assignment, which is already on the web. But in fact, firms are going to maximize profits, aim to maximize profits. Firms are going to have constant marginal costs. We'll make one other assumption to keep life simple. We'll assume that each consumer buys one and only one product. Right? So each consumer is going to buy one product, either from firm 1 or from firm 2. All right? So the issue is going to be, which firm does each consumer go and buy their product from? Right? Which firm does each consumer choose? And we'll assume that each consumer chooses the product whose, and I'll be careful here, whose total cost to her is smaller. And what do we mean by total cost? Well, let's just look at for the consumer at point Y. For example, for the consumer at point Y, if they buy from firm 1, then they pay the price, P1, which is set by firm 1, but they also have to pay a transport cost, the cost to them of having to walk all the way there and walk all the way back. All right, and we'll give a name to that transport cost. We'll say it's T y squared. Right, so y is the distance they have to travel, right? And ty squared is their transport cost. Right, so this object here we could think of as a transport cost. Right? If the same consumer buys from firm 2, she pays P2 plus T times, again, the distance squared, so that's going to be 1 minus y squared. And once again, this last term is a transport cost. All right? All right, notice that these transport costs go up in the distance you have to travel, and they go up pretty fast. They go up at rate squared. All right? So what you're going to do on the homework assignment is solve out this market. You're going to assume that firms set prices to maximize profits. You're going to know what firms' costs are. You're going to work out what firms' demands are going to look like for each possible prices they could set. And you're going to solve out the whole Nash equilibrium. And then we're going to look at that Nash equilibrium, and you're going to think, how does that compare to what I saw in the Cournot case and so on? All right? So that's on the homework assignment. But before I leave this, let me just point out that this is a little bit more general than it might appear. So here, I've treated what makes products different as being where the shops are located. Right? So here I've interpreted these terms here as transport costs, and I've interpreted what makes the products different is the fact that one of them is selling at one end of the town, and the other one is selling at the right-hand end of town. All right? But actually, we could consider this model more generally. Let's just do so briefly here. So let me just redraw the town. Here's my town again. All right? I don't have to regard this line as being distance along the high street of the town. It could be something else about the product. So for example, in whatever it is you guys imagine makes Coke and Pepsi different, it could be that thing. I don't quite know what that is, but whatever that is. Let me take an example that I understand better than I understand Coke and Pepsi. So imagine we're talking about beer. All right? Think about beer. So this is the beer market. All right? This distance here could be something like the alcohol content or the flavor of the beer. All right? And you can imagine different products, therefore, that are on the market positioning themselves or being positioned at different points on the line. So, for example, up here, if we're talking about beer flavor, this might be Guinness. All right? This might be Guinness, which I can't even spell, but you know what I mean. All right? And if you think about the drinks industry more generally here, rather than just beer, this would be Guinness. This would be Poland Spring. All right? This is water. Right? And everything else would be in between here. All right? So if we just go a tiny distance in here, all right, this is Bud Light. Right, and so on, right? Right? You could put everything on this line, all right? All right, I think there may be, I'm not really allowed to do this on this model. The one thing I can't do is, part of the truth is, Bud Light might be down here somewhere, but I'm not allowed to do that. All right? All right? So, leaving aside the specific example of beer, you think about some product that has some dimension on which it varies, and we can use this model to see how competition is going to work in that market. But now, notice that this transport cost is going to be a different interpretation. Now, instead of being the cost of traveling that distance to go and buy the product, what's it going to be? It's going to be that if my preferred beer flavor is here, say, this is me, my preferred beer flavor is here, then if I end up having to consume Guinness, I have to pay the price of Guinness, and I also incur some costs because Guinness isn't the perfect beer for me. It's a little bit too strong. All right? And if I consume Bud Light, then I have to pay for the Bud Light. I think typically costs less. The raw price is less than Guinness, but I also pay an additional cost from the fact that the Bud Light, when I drink it, causes me dysutilities. We put that politely like that. All right? All right? All right? So basically, that transport cost is now the lack of pleasure caused by drinking a product that isn't perfect for me. All right? Does everyone understand the story here? All right? So you're going to figure out what happens in this story very generally, well, not very generally, in the particular case, actually, on the homework assignment, but I want you to understand that there's this much more general story underlying this, and this is a pretty good model of how, of a lot of markets. It's a kind of model that you'd see again if you went on to graduate school. All right. Now I want to spend the rest of today doing something quite different. But you'll see it isn't all that different. I'm going to go away from studying imperfect competition and go back and visit something we studied almost the first day, or maybe the second day, and that's elections. I want to go back to elections, and why do I want to go back at this point? Well, one reason I want to go back is you'll notice I've been putting up these lines on the board, and when we visited elections on the second day, we said that you could think of that line on the board as being not just left-wing, right-wing politics, but also some dimension of product. So I want to go back again. Now we're considering the line on the board as being flavor in beer or location in a town. And I want to go back to politics now and go back to the interpretation we started with so that left and right will end up being left-wing politics versus right-wing politics. Right? So I'm going to take the same basic idea back to the politics model. And we'll spend the rest of today in politics. So we're going to be doing political science, or political science as it meets game theory, for the rest of the day. We're going to study something called the candidate-voter model. Candidate-voter model. Right? And this model is going to look a lot like the models we looked at already a few weeks ago. In particular, as advertised, there will be a line, and this line will go from 0 to 1, and the left-hand side of this line will represent the left wing, and the right-hand side of the line will represent the right wing. So that's the same as before. And as before, as in the Downs or Hotelling model we discussed already a few weeks ago, we're going to assume that voters are evenly spread along the line. All right, so we're going to assume even distribution of voters on the line. And we're also going to assume, just as we did last time, that voters are going to vote for the closest candidate. So voters vote for the closest candidate. So all of these assumptions are the same assumptions we studied 2 weeks ago, or 2.5 weeks ago, and which you actually studied in your first homework assignment. Is that right? But I want to go back there, because what I want to do now is I want to change some critical assumptions of that model and see that by making those changes, we're going to get some very different outcomes. So in particular, the new things here, two things. One, the number of candidates is not fixed. So the number of candidates in this model is going to be endogenous. All right. Previously, we'd looked at models where there were 2 candidates, or on your homework assignment, 3 candidates. Now we're going to allow the number of candidates to adjust itself. And the second assumption we're going to make, which is new, is that we're going to assume that candidates cannot choose their position. Right? So the idea is, any candidate who stands in this election, you know who that candidate is. You know whether they're right wing or left wing. So they can't tell you they're something else. Right? So candidates cannot choose their position. All right? So this is a subtle thing, right? Because you think about the current election, there's a debate about whether Hillary Clinton, for example, can choose right now to be at the center of the Democratic Party, given her past history of votes, for example, on the Iraq War. Or on the other side, there's a debate about whether Mitt Romney can choose to be, I guess he's trying to choose himself to be on the right-hand wing of the Republican Party, given he has a record of government as being governor of Massachusetts when he provided state health care, for example. All right? So it's quite difficult in the real world for candidates to position themselves. Voters tend to know that those candidates have track records. That's something we mentioned already 3 weeks ago, 2 weeks ago. We're going to take that fix now. We're going to assume you know who these candidates are. All right? So what are we actually going to assume? We're going to assume that each voter in the model is a potential candidate. So this is, I think, a nice idealized version of American politics. Each of you who is above 18 and is an American citizen and was born in America, and maybe you have to be more than above 18, above whatever it is, whatever the rule is, whatever the Constitution says, each of you can potentially stand up now and say you're going to run for president. Right? I'm guessing all of you are ruled out by age, actually. There's some rule in the Constitution, but never mind, let's pretend that's not there. Right? So the idea of the model is each voter is a potential candidate. All right, that's a very appealing assumption, I think, in a democracy. So what I want to do is I want to lay this out a little bit more formally as a game, and then, since we haven't done anything like this for a week or so, we're going to play the game. All right, so you're about to play this game, so pay attention, please. All right, so who are the voters? Who are the players? The players are the voters. Right, the voters or candidates, whatever you want to call them. Candidates, depending on where they stand. In this game, they're going to be you. And the key strategy here, essentially, the strategy is going to be very simple. The strategy is, do you run or not? The reason that's going to be the strategy is that voting's not going to be difficult. You're always going to end up voting for the candidate who's closest. Right? So the only really relevant strategy is to run or not to run, to stand or not to stand. All right? So just to make that clear, voters vote for the closest running candidate. First. And second, what does it mean to win? We'll assume that we're in a plurality election here. So the winner is the person who gets a plurality. You win if you get the most votes, in other words. You win if you get the most votes. And we'll assume that if there's a tie, that we flip a fair coin or a Supreme Court judge, whatever you want to take it, whichever. Right? So flip if tie. All right? And the payoffs in this game are as follows. We'll assume that there's a prize for winning. So if you win the election, you get a prize equal to B. All right? We'll also assume that there's a cost of running. So if you enter this election, win or not, you incur a cost of C. And we'll assume that B is greater than or equal to 2C. And actually for today, let's just keep things simple and assume it's actually equal to 2C. All right? But that's not the only part of the payoffs. There's also a part of the payoffs that's analogous to forcing me to drink Bud Light or forcing the Pepsi drinkers to drink Coca-Cola. And what's that? That's if, regardless of whether I run or not, if some other candidate is elected other than me, then they're not going to have my ideal policies. All right? So it's going to cause me unhappiness, it's going to cause me disutility, having a candidate win who's far away from me. All right? So there's going to be an extra thing, and So if your position is x, if you are at x on that line, and the winner of the election is at y, then you pay a cost of minus x minus y, the absolute distance between you and the winning candidate. So again, if you're at x and the winner's at y, it hurts you minus the distance between x and y in terms of your unhappiness at having a winner who's far away from you winning. So let's do an example. So make sure we understand the payoffs. So example 1, if you're at x, let's call you Mr. X. Let's call him Mr. X, make it clear. So Mr. X, person who's at position x, if he enters the election and he wins the election, then his payoff is B because he entered, minus C, sorry, B because he won, minus C because he had to pay his election expense. Right? But the winning candidate is him, so he gets no disutility from the winning candidate being someone else. Right? Second possibility, if Mr. X enters but Mr. Y wins, then X's payoff is what? He still incurred minus C because he ran, and he also has a cost of X minus Y because he doesn't like Mr. Y winning. Right? And third, if Mr. X stays out, but Mr. Y wins, then Mr. X's payoff, he doesn't win, so he doesn't get B. He doesn't lose C because he didn't run, but he still has this disutility minus X minus Y because he doesn't like Y winning. All right? Does everyone understand this game? Everyone understand the game? They do not understand the game at this point. All right, so in principle, we could play this with the whole class, but let's single out a particular row of the class. So I'm going to come down here, and I guess eventually, well, I'll grab it in a minute. All right, so I'm going to use this row, I think. This row, OK? This row. Just everyone in this row stand up a second. Okay, and this row stand up. All right. This is the row of potential voters. Sorry, they're the voters. They're also the potential candidates. All right. So we need to have a convention here, whether we're viewing this from the perspective of people behind them or people in front of them. Let's view it from the perspective of people in front of them. Oh, I got an R. OK, I'll do the other way around. People from behind them have the perspective. OK. So this gentleman here, whose name is Andy, thank you. So Andy is our crazy right-wing guy. All right. And Sidipto is our crazy left-wing guy. Right, and everyone else is in between. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 people here. Let me add, make it 17 people so we have an odd number. So go and sit in that row. Yeah. Let's go sit somewhere there. OK, now we have 17 people. It's a bit easier. All right. Just want to avoid obvious ties. OK. All right. So how's this going to work? Everybody sit down again, but don't keep your books handy because this is going to be pretty aerobic. All right. So these are the potential voters, and each of them is in the position that Fred Thompson was in 2 weeks ago in the Republican primary when he's deciding whether to run or not. All right? But in the real world, that's a sequential game. People decide to run in some order. We're going to assume this is all simultaneous. All right? So what we're going to do is we're going to hold essentially this game. Right? We're going to ask everybody in this row, right, whether they want to enter or not. Let's make some real numbers. So let's assume that B is equal to $2. So the spoils of government are $2. And entering costs you $1, so C is $1. And we'll assume that the amount of disutility you get from being far away from the winner is 1/17 of the each place is worth 1/17 of a dollar. All right, everyone understand? So whatever 1/17 of a dollar, roughly 5 cents, for each position away. Okay, everyone understand in this row what we're doing? I'm not getting any nods. You guys over here, you understand what we're doing? All right. So on the count of three, anybody who's entering this election is going to stand up. Ready? 1, 2. Okay, what? That's the opposite of what's happening with the Florida primary. Yeah. Question.
I'm sorry.
Go ahead.
Stands up on the kind of
You guys have to decide whether you, okay, so if you're running, you stand up. Okay, if you're standing, you stand. All right, if you're standing, you stand. All right, let's try again. 1, 2, 3. Come on. All right, stay standing, stay standing. And I'll come around a second. All right, so here's our election, and it's between which way down do we do it? This is our left-wing candidate. This is our moderate left-wing candidate, whose name is Alex. And our kind of centrist candidate, maybe even the centrist candidate, whose name is Beatrice. All right. So this is the election. Who's going to win this election? Right? Beatrice is going to win this election, right? But let's just check that. Beatrice is going to get, for me too, Beatrice is going to get all of these right-wing votes, right? Beatrice is also going to get 1.5 of the votes in the middle, so what, right? So this vote and half the Pearson guy's vote, right? And I've forgotten your name already again. And Alex is going to get all the left-wing votes, but there aren't enough left-wing votes here, right? So Beatrice is going to win. All right, so Beatrice won this election. Is this array a Nash equilibrium? Is this an equilibrium? How do we know it's not an equilibrium? Katie, how do we know this is not an equilibrium? Wait for the mic. How do we know this is not an equilibrium?
Because Alex, best response to her running is to not run.
Absolutely. So Alex ended up with a payoff of what? Alex ended up with a payoff of minus C, actually more than that, minus C minus the distance between him and Beatrice, so that's another $1, 5 cents, 10 cents, 15 cents, 20 cents, whatever it is, right? And he would have done better than not to run. If he hadn't run, Beatrice would still have won. It would have still cost him the 20 cents of unhappiness at Beatrice winning, but at least he'd have saved himself the C of running. Everyone see that? Let's try it again, okay? Okay, same row, but don't hesitate so much this time, right? Count of 3, you've got to just go or not. Everybody in this row close their eyes. So you can't look around you. Close your eyes. We can do all sorts of nasty things. Close your eyes. All right? Mercy, you're still in this row, okay? All right. So, ready? All right. So, 1, 2, 3. All right, you can open your eyes again. All right, so now what happened? We end up with 2 centrist candidates. Let's see what happened. So we have Beatrice, and your name is? Claire-Elise. All right, and Claire-Elise is going to get her own vote plus 1, 2, 3, 4, 5, 6, 7, 8 votes. And Beatrice is getting 1, 2, 3, 4, 5, 6, 7. How did I end up with 8? I had an odd number. 1, 2, 3, 4, 5, 6, 7. It must have been an odd number 4. Okay, so Claire-Elise is going to win this election, all right, because you've got 1 more vote. Now here we ended up with 2 centrist candidates, which is a result pretty close to what we saw in the hoteling model. Is that right? Is this an equilibrium? So check I counted right. 1, 2, 3, 4, 5, 6, 7, 8. And so 1, 2, 3, 4, 5, 6, 7. I guess they do count right. So Claire-Elise turned out to win this. I counted that correct. Oh, there's another vote hidden behind there. I didn't see you. I didn't. Yeah, okay, so let's just try again. So 1, 2, 3, 4, 5, 6, 7, 8. I apologize. Beatrice won this election. I apologize. Beatrice won this election. All right. Is this an equilibrium? How do we know this isn't an equilibrium? Because Claire-Elise would rather not have run. Is that right? All right, let's try once more. All right, down again. Close your eyes again. Let's just to keep life interesting, let's switch to this row. Can we switch to this row, okay? All right, so this is our row now. Everyone understand this? Close your computer so you can get up without destroying thousands of dollars of technology. All right? This is our row. And at the count of 3, we're going to see who's going to run, OK? Everyone understand the game? All right? Close your eyes. Close your eyes, madam. 1, 2, 3. All right? All right. So OK, so it's obvious he's going to win this election. Is that right? All right. And just ask the question, is this an equilibrium? Is this an equilibrium? Is he in the, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. He's going to get 10 votes. So there are 10 votes, including himself, there are 10 votes here. I can't count correctly. 1, 2, 3, 4, 5, 6. Is he actually the center guy here? I don't think he is the center guy here. All right? So I claim, if I've counted correctly, that this actually isn't an equilibrium. Right? Who can deviate and do better here? Yeah, this guy. Stand up a second. Whose name is? John. So had John entered, if I've counted correctly, let's pretend I have, John would actually have won this election because John is actually further to the center. All right? All right? OK. So thanks for a second, guys. I'll come back to this in a second. All right? All right. Let's try and figure out how to analyze this game. We've played it 3 times. Let's try and figure out what the equilibria look like in this game. Right? This game that's going on more or less right now in the primaries. Well, I guess the entry stage of it is gone now. All right. So first of all, is there a Nash equilibrium in which no candidates stand? Is there a Nash equilibrium in which nobody stands? No. How do we know that's not a Nash equilibrium? Somebody? Somebody? Yeah. How do we know that's not a Nash equilibrium? Shout it out.
Because then somebody's definitely better off by standing up.
Right. If nobody stands, each and every possible candidate would do better individually. So any particular voter would do better standing. They would win the election. Is that right? All right. So clearly it's not an equilibrium for nobody to stand. That's good because we don't see that very often. All right. Is there a Nash equilibrium in which one and only one candidate stands? Yeah, so
if they're directly in the center.
All right, so given that we chose an odd number of people in the row, if exactly one candidate stands and that candidate is the center candidate, then that's an equilibrium. How do we know that's an equilibrium? Somebody give me the argument why that's an equilibrium. So it's in fact a correct guess, but how do we know that's an equilibrium? That's the guess part. How do we check that's an equilibrium? Yeah, Clarice. Shout out.
Okay. If anybody on either side of them chose to run, they would lose.
They would lose, exactly. So if anybody on either side of them runs, right, that person would simply lose. It wouldn't make any difference to the outcome. Right? If a person on the right stood, so let's just try it again. So we figured out that, that if Beatrice stands up a second, right? So here's our potential equilibrium with just Beatrice standing, right? And if somebody to the, which way are we doing it? Somebody to the right of Beatrice was to stand. So madam, if you stand a second, and your name is? Stacey. So if Stacey stands, it doesn't make any difference. She just loses. Beatrice wins anyway. It just costs Beatrice some money, right? And conversely, if Beatrice doesn't stand, and sit again a second, and the woman who's won in from the side there, so sit down a second, Stacey. And if this person stands, and your name is? If Sarah stands, it doesn't help Sarah at all. She just loses. Is that right? So there is an equilibrium with exactly one candidate, the center candidate. Now that's looking a little bit like the median voter model, right? It says there is an equilibrium with only one candidate standing, and that candidate would be the median candidate, right? Just like it was in the model we saw on your homework assignment and also in class. However, we're not done yet. There could be other equilibria. There could be other equilibria. All right? So let's just try and think about whether there are other equilibria. So for example, suppose now, just to make life a little bit more interesting, suppose that the voters were actually 2 rows, and just allow me the suspension of disbelief that these rows have the same number of people in them. I know they don't really. All right? So now what I want you to think of is at every political position, there are 2 voters and hence 2 possible candidates. Right? There's two people at every position. These two people are at this position. These two people are at this position. Right? Everyone understand that? And let's assume that the rows are the same even though they're not. And let's examine the following thing. Suppose Beatrice stands again, sorry Beatrice, and the gentleman in front of him, in front of her, whose name is Robert, stands as well. So stand a second. All right? So now we have two candidates standing who are identical. Politically, they're identical. Right? They're right on top of each other. All right? Now, is that an equilibrium? Is that an equilibrium? After all, I mean, that looks a lot like the down to telling model, right? We've got two candidates exactly at the middle. Is that an equilibrium? Let me try the guy up here.
No, because if someone on either side of them were to stand up, that person on the side would win.
Good, good. This can't be an equilibrium because look what happens if Claire-Elise stands a second. All right? Claire-Elise is going to win all of the right-wing votes, right, ranging from crazy to moderate, right? And these guys are going to split the left-wing votes, right? So the total sum of right-wing votes is going to beat out half of the left-wing votes, all right? Right? So it can't be an equilibrium. The exact prediction of the Downs model, two guys right on top of each other, is not an equilibrium. Sit down again, guys. All right? All right. Let's go back to one row again because it's easy to work with. All right. Let's try a slightly different pattern. So suppose, assuming I counted right, suppose that the following candidates enter. So Claire-Elise enters, and I'm sorry I don't know your name. Jean. Jean enters. So let's have a look at this array. All right? And assume I got it right and Beatrice is actually the center. All right? Now, is that an equilibrium? Is that an equilibrium? Who thinks that is an equilibrium? Who thinks it's not an equilibrium? Who's waiting to see how other people vote? Well, let's check. Let's check. All right? So there's three possible types of deviation here that we need to check. We need to check another entrant from the outside, left wing or right wing. We need to check another entrant in the middle. There is only one possible one there. And there's a third kind of deviation we should check. What's the third type of deviation? One of these might choose not to run. One of you might might choose not to run. Let's do them in turn. So suppose that we consider a deviation in which, and again I've forgotten your name, in which Stacy stands as well. Stacy, just stand a second. All right? So is this a profitable deviation for Stacy? No, it's not, right? It's not. Why isn't it a profitable deviation for Stacy? So two reasons. Hang on, stay up there a second. One is that she loses. Right? She's not going to win this election by standing. But there's a second reason why this is a really bad deviation. Why is it? What's the second reason? Yes, sir.
The winner is going to be farther away from her.
Good. Good. So by standing, not only does she not win the election, but she actually causes the election to be won for sure by Jean, who's further away from her. That's right? So Stacey's going to pick up the right-wing votes. She's going to split the crazy right-wing votes she's going to pick up. The moderate right-wing votes she's going to split with Claire-Elise, right? And Jean's going to have all the left-wing votes, extreme and moderate. And so from Stacey's point of view, this is a double bad. She doesn't get to be president, sorry, and you end up with a left-wing president which you didn't like. Right? Everyone see that? So clearly that's not, thank you, that's not a profitable deviation. Hang on, wait, you guys, wait, guys. And it's also not a profitable deviation for people on the left. Hang on a second. All right? So I think it's probably obvious why it's not a good strategy for Beatrice to enter here. If Beatrice enters, she loses. Right? Everyone can see that. The person in the middle, if they enter here, loses, so they're not going to want to enter. All right? So the other possible deviation we have to consider is a deviation of the form of one of these guys dropping out. All right? So let's consider it. So come back to Claire-Elise. Is Claire-Elise doing better in or out? Is Claire-Elise doing better in this election or out? All right, let's think it through a second. If she stays in, what's her payoff? She wins B with probability a half. She costs C for sure. That's a wash, right? Because B over, the way we've worked things out, B was $2, C was $1, so B over 2 minus C is a wash. All right? In terms of So in terms of the benefits of the spoils of government versus the cost of running, it's a wash for Clarice whether she enters or not. Right? But by entering, she has a half chance of winning the election. All right? So one way to think about it is the expected distance from her of the winning candidates is, with probability a half, it's herself, that's nothing, no distance, and with probability a half, it's 2 places away. Right? So an expectation, it's 1 place away. If she drops out, Jean wins for sure. All right? So the expected distance away from her of the winning candidate is 2 away. All right? Just say it again. So the cost and direct benefits of government are a wash for her. But by dropping out, she ensures that somebody further away from her wins for sure. That's bad, so she's going to stay in. And the same argument goes the other way. So this is an equilibrium. Now we're not done, and of course we're out of time. So what are we going to do when we come back next week? What are we going to do? Don't pack up yet. What are we going to do? We're going to come back to this row, and we're going to figure out not just this equilibrium, but all equilibria. Before you go, though, let's just think about it a second, so you can think about it and talk about it at home. So what we just saw was an election in which we saw 2 candidates, Jean and Clarice, who both stood very close to each other. But a different question is, hang on before you go, stand up my very left-wing guy. Yeah, so dip way at the end, way there. Yep, up. Yep, and stand up my very right-wing guy. Here's a candidate, here's an outcome with 2 entrants in it, an extreme right-wing guy and an extreme left-wing guy. Is that an equilibrium? Think about it until we come back on Monday.